So my name is Paddy Cullen. I'm a lecturer in renewable energy in the Department of Engineering, School of Engineering and Material Science. And my research is all about making nanomaterials. Nanomaterials are materials which have at least one dimension on the nanoscale. So that's very, very small. So something like a thousandth the width of a human hair. And when you get materials on that scale, you get some very interesting electronic properties, which can be useful for things like batteries, fuel cells, and other electrochemical devices, which I'm interested in improving. And so I make these nanomaterials in ways which are scalable, so that we can not only make enough for a lab, but be able to one day make enough to make 1,000 phone batteries or 1,000,000 phone batteries. And I take those nanomaterials and I try and embed them in the correct architecture for these devices. So you might want these nanomaterials arranged in a certain setup for a battery, and you want them arranged in a different setup for a hydrogen fuel cell, for example. So a hydrogen fuel cell takes hydrogen gas, puts it into this device, and it converts the hydrogen gas into electricity. It does this by reacting the hydrogen on one side of the fuel cell with oxygen from the air on the other side of the fuel cell. And by combining these electrochemically, you get H2O, which is water. And you get the electricity out, which can then be used to power your vehicle or your industrial process, whatever you would like. And so we are testing and developing fuel cell materials. One of the materials that is one of the big bottlenecks for hydrogen fuel cells commercialization is the catalyst. And the catalyst is this material which allows for these reactions to proceed. The problem is the catalysts at the moment are made from very expensive, rare metals. So the best catalyst for this is platinum, which is obviously a very expensive material. And so researchers, and as part of my research, we try and reduce the amount of platinum needed in these fuel cells. So people are working on these catalysts to make the fuel cell cheaper and also to make it more scalable, as we have much more iron on the earth that we can dig out of the ground than we have platinum. So in my research, I use a lot of facilities here at Queen Mary. The main facility I use to do all my air-sensitive work is in a glove box. And a glove box is essentially a box with gloves in it, which allows you to reach in and do chemistry, assemble batteries. And inside this environment, it's filled with argon gas. And argon gas doesn't react with metals such as lithium or sodium that you might find in your batteries. And that's why it's important that I need this facility. I also design batteries and different cells for large facility work. I've just been working on a lithium-ion battery that can go into a neutron beam. By developing operando techniques, as they're called, you can see what's happening inside the materials of a battery whilst the battery is running. And that's really important in order to be able to iterate the materials that we're putting into the batteries. So we need improved materials to improve the batteries. We also need to understand what these materials are doing inside a battery when you charge and discharge it. And so by using these operando techniques, we can look at the battery charging and discharging and find out about how the materials behave inside that battery. With that information, we can then go on to tune our materials to further increase performance. So in my work, commercialization is really important, to be able to take materials I make in the lab or make these techniques to put these materials within another material for a battery or fuel cell. And to do that, I have written a few patents, which I'm hoping to use in order to get funding to spin out some companies to try and scale up the manufacture of these materials for batteries and fuel cells. And partnering with industry is a very good way to try and do that. So the impact of my research on a larger scale are quite obvious to me. They are environmental. And if we are moving away from internal combustion engines from cars, for example, be it petrol or diesel, then we need to have batteries that can charge quickly, store a lot of charge so you can drive between cities without needing to refuel. And they need to be recyclable. And these are there's a lot more challenges than that. But these are issues that really need to be addressed in order to turn the car fleet greener.